I am Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about the computer network subjects, in which the topic is a quality of service and internetworking. Here the outcome of the quality of service and internetworking is which is the providing the seamless communication. Seamless communication means now which is enabling the connectivity between the diversity the networks for the efficient data sharing and collaborations. And here the scalability and net integration is another the outcome of the network the sharing, and supporting now which is the scalability and integration, which is supporting the network growth and interoperability across the global systems. Next, the outcome is the optimized routing. This optimized routing here now, which is the finding the ensure and finding the best the route and best the path can be the find, which is ensuring efficient data transfer and resource the utilizations through the intelligent the routing the protocols. These three are the outcomes of quality of service and internetworking. Here is the quality of the service in a computer network. The quality of service means that means now whatever the data now we are going to the transferring. Here is quality of service means whatever the data we are going to transferring from the source station to destination, which we have to transfer the without loss. The data loss now we have to transfer the data without loss. That is the quality of service. Providing within time now the required data now we have to transfer. If you transfer the data from source to destination within this the time delay, we are saying it as which is having the quality of the services, which is refers the ability of the network now, which is providing the better services to selected network traffic. Whatever the network now we have the selected, so to that the selected the network now, if you are transferred the data packets without the time delay, we can say it as a quality of the services. Same data without loss and without time delay, if you the transfer by using the various other technologies now, or by using the various other protocols now, if you transfer the data effectively without the loss, it is we are saying it as it is a quality of the service now. Generally the real-time applications of this the quality of service now, we can say it as a voice over the IP. Voice over the IP means now, for best example is a mobile communication. Mobile communication, it is a voice over the IP. So this is the real-time the applications of the quality of the services. Now video the conferencing, online gaming. So these are all the real-time applications of the quality of the service. Here the quality of the services, generally various types of the traffic, the quality of the services the measurements is there. The quality of the services are reliability. One is a reliability. Reliability means now the data without the loss, the data packets now we have to send from source to destination, that is a reliability. And delay, so generally within the time limit. Delay means now which is proportional to the other time. If the data packets are not sent to the destination within this the time limit, or suppose if it is taking the long time to transferring the data packets to the other destination, now we can consider as a other delay. So delay, so it may be causes the data losses or packet losses while transferring the other data from source to other destination. So it will be, if it is the delayed means now, it may be the data may be the losses, which is losses or which may take the long time, more other time than the whatever the time you have set for transferring the data from source to other destination. That setting time now, which is taking the more time than the comparing with the whatever the time you have set now, so which is take the more time than the setting time. So that is a delay. And a jitter means now here it is a time variation. Delay means now it is time is taking more time for data packet transferring. So it may be the causes the router failure, or it may be the transmission failure or path failing, whatever it may be. The delays will be caused for the data packet and the transparency. And the jitter means now variation of the time variation. Here is the time and the variation. So if the delay is increased, the data packet transparency of the delay is the increase means now jitter time. Jitter time, the variation, time variation, that means jitter time is decreased. Delay is, so the delay is the decreased. That means now the jitter time, that means the time variation, that data packet, the time variation will be the decreased. Here if it is increased, it will be the increased. If it is a time variation will be increased, and suppose if it is a decrease, it will be the other decreased. Now here this is about the jitter and the bandwidth. Bandwidth, now if we take the bandwidth, based on this the bandwidth, which is depends data transfer rate. Mainly we can determine the data transfer rate, transmission rate can be determined based on the bandwidth. Suppose if the transmission, the media, the bandwidth is a more bandwidth, now the data transparency, more data can be transferred. If it is a bandwidth is a less bandwidth, now the data transparency should be the very less data transparency can be transferred. That is a, and next one is a loss, data loss. Data loss now, which is a reliability. Data may be losses due to the failures of the router, or failures of the path, failures of the connectivity, and failures of the switches, whatever the devices, whatever the devices now we have arranged between source and destination, so it will be caused. That is a loss, data packet loss may be caused. So loss now, which is identified by the sender. The sender, suppose the sender sending the data to the destination. If the destination is not acknowledged, now the sender is, which is assume it as the data packet will be the loss due to the some other congestions, or it will be the failure of these the devices, that means the switches, routers, and the hub. Now which leads to the data loss. Now it is these are the four. These four are the quality of service of the measurement or the internetworking. So internetwork, various the types of these the traffics now it will be considered these quality of measures will be the considered. These are the components of the quality of the services. And bandwidth now, which is sufficient data transmission rate of the high priority of the applications. If bandwidth is a more bandwidth, now data transfer rate should be very high. Data transmission rate will be very high. If the bandwidth is a less, now data transmission rate will be the very low data transmission rate from one device to the other device over the network. Delay means now, which is the time sensitivity application. Depends upon this, it's at a time. No, so it will be the minimizing latency to maintaining the performance in a time sensitivity applications. So which time delay means now, which is based depends upon the time it takes for the packet to delivering for the destination, from source to the destination, time taken. So which is depends upon the time taken for data delivery from the source station to the destination station. Here the jitter means now, jitter is a irregular speed, that is a time variation, speed of the packet on a network as a result of the other congestion. That is a time variation. One packet will be reaches to the one time, another packet will be reaches to the another time. That is a time variation of this other time. If it is a delay is a more, the jitter time also more. If the delay is a less, the jitter time also, it's a very decreasing the jitter time, which can result in a packet arrival late out of this other sequence. Now, which is indicates jitter time is now how much the late is arise from one packet to the other packet. Setting time and whatever the time you have set, that is a variation. Jitter time means now it is a delta t is equals to t2 minus other t1. Here that is a t2, it is a your packet. Now whatever the packet you are going to the transferring, That is the time for setting for the data transfer of that the packet. So this is a delay time. T2 is the delay time. That is a delay time. Suppose if you set the time as a 10 milliseconds packet delivery time, and the packet is the delayed. The packet is delayed as a, so actually the packet is reached at 14 milliseconds. That means now the delay is 4 seconds. So this is a jitter time variation. Time variation with this 4 milliseconds late, now the packet will be arrived. So this is the jitter at the time. Packet loss, that means now which is tends to the reliability of the data transmission. So packet loss now, which is preventing the loss of data packets. Here is now loss of the data packets. So that the data packet loss now, which is ensuring the reliability, and also the amount of data lost as a result of the packet loss. Data loss as a result of the packet loss now, which is occurs due to the network other congestions. Generally, the packet loss will be the occurred network congestions and overloaded. Whenever the data is overloaded, the capacity of that at the network now, so this the packet loss will be happen. If it is the packets are lost now, reliability will be the decreases. If there is no other packet loss now, if you transferring the data without the packet loss, the reliability will be automatically increasing the reliability. Here is the quality of the service. Quality of service, if it is reliability is increased, quality of service also improved over the network, and which is enabling the organization. So that means now which are the packets to drop in this other event. Now which will be the quality of the service can be, that depends upon the packet loss. If the packets are lost, more number of other packets are lost here, generally the quality of service will be decreased. If there is no loss, now, if you are going to transferring the data packets without loss, now the quality of service will be improved, or quality of service will be increased. So this is the packet loss. This is about the packet loss. Let's see quality of service and the mechanisms. Quality of the service and the mechanisms, now different types of this quality of the service mechanisms is there over this internetworking. Here is the traffic shaping. Traffic and the shaping means now generally, so these controlling the traffic and and fixed rate of continuous, the constant rate of the information can be transferred, traveling these constant data packets can be traveled with a desired rate, fixed rate of value. Desired rate or fixed rate of data value, now the packets will be traveling from one network to the another network. So with the traffic shop and scheduling, different types of these scheduling is there, that are FIFO, first in first out. So this is a very simple scheduling technique. That means in this first in first out, in this the mechanism, whatever the packets are so reach to the first at the switches now, so that the packets can be transferred to the first. That packets will be first relieved the first. That means first out, first in first out. Whatever the packets are coming first, so that will be released the first. And priority queuing. Priority and the queuing means now the packets, whatever the packets are reaches to the that are the switches. That switches now which is the maintaining the one queue. All the packets can be kept in a queue. Based on this the priority, whatever the packets now having the high priority, based on that the priority level, the packets can be delivered to the network destination now, which will be transferred over the network and delivered to the other destination. Assigns the priority of a different traffic types. Here is the based on that low, suppose the packets are having the low priority, so the low priority packets will be sent to late. That means now which is giving the chance to the last chance will be given to the low priority packets. High priority packets, now the chance will be given to the high priority packets for first. This is a priority queuing, storing and in a queue based on the priority, and from that the priority that will be sent out first. Weighted and the fair as the queuing. Here is next the mechanism is in scheduling. Weighted as the fair as the queuing. Weighted WFQ, weighted fair queuing means now which is allocate the bandwidth proportionality among the traffic flows. Based on this bandwidth now, data the traffic will be varies. If the bandwidth is more the bandwidth, now the no need to maintaining the data packets in a queue. Whatever that data packets are arrived here, that the data packets now continuously transfer to the destination. So this is the traffic flow. That is a bandwidth, the proportionality. Allocation should be done. So bandwidth is a low bandwidth now. The allocation should be the very less allocation can be done to the other queue. If it is a bandwidth, the more bandwidth, the allocation speed will be increased to the other queue. Number of data packets can be allocated and number of data packets can be transferred to the over the network to the other destination. That is a weighted fair the queuing. WFQ. That depends upon the bandwidth. The allocation of these other queues, it will be depends upon the bandwidth. And the policies. Main here, the policies, different of the policies can be applied for data controlling. For traffic controlling now, generally applying the different other policies, by applying the different other policies now, traffic can be controlled over the network. Why? Because here, if it is not applied these are the policies and these are the traffic other policies now, the congestions will be arise and data will be lost. So that means the if the data is lost means now reliability of the network will be the decrease. By discarding the other packets now, which is exceeding the specific rate, data discarding now the specific rate now, it will be discarding the other packets now, which will be specific rate of the interest can be either decreased. The admission and the control. Admission and the control means now which is controlling the admissions, controlling the data entry into the network. So why? Because now which is ensuring the authorized packets only. So entering the only authorized the packets now from the sender mission, from the sales is a sender mission now, it is a and destination mission. So what the sender mission now sending the packets, which is the permitting the packets. When it is permitting the packets, that means now if it is authorized, now permitting the packets. Suppose if it is not authorized, means now that other packets now whatever the other packets we are going to sending here, that packets can be denied, and that will be sent to the finance other department, different other departments. Now the communication can be done via the routers and the switches. If it is the permitted means now it is a permitted to the internet. Permitted to the internet means here that packets should be the authorized packets. Only the authorized packets only the permitted to the internet. So by permitting it to the internet now, the authorized packets that can be transferred to the via the routers. Via the routers now, these are the packets can be transferred via the router to the particular the destination. That is a destination is a marketing the marketing host. That is a destination device. Now each and every device having its IP addresses. Based on these IP addresses now, the packets can be either transferred. That means the addresses to the authorized IP addresses. So based on these authorized the IP addresses now, the traffic, the data packet and the traffic can be entered into the network. Here this is about the admission control mechanism. Quality of the service architecture. So this is the quality of service architecture. So in this, the quality of the service architecture, which is working with the integrated services plus differentiated services. With help of both integrated and differentiated services now, the quality of the service can be provided. That means quality of service means without the data loss. Data can be transferred without the data loss. This is a internal structure. Quality of service means internal structure of the quality of the service within these other devices. That means if you take integrated services, these integrated services now which is providing to host to host quality of services. That means end to end quality of services. So end to end means now one end which is having the one computer machine, another end which is having the other computer machine. End to end quality of the services. for a specific flow using the RSVP, that is a resource reservation protocol. Specific flow using the RSVP, resource reservation other protocol. Differentiated services. Differentiated services means now which is using the other traffic, different other traffic classes. Different other traffic classes now to prioritize the packets without the per flow state other maintenance. So this is a differentiated other services. By integrating these two services now, we can provide the more quality of data transfer from the source mission to the destination mission. Here, quality of other services now, in this the diagram now, which is integrating both integrated services and differentiated services, which is highlighting their quality of service mechanisms, which is highlighting the quality of service mechanisms and providing the more qualitative data services from source to destinations. And if you say internetworking, so internetworking now, which is the combination of two terms. One is a inter, another one is a networking. So global, inter means here are the global. Networking means now the connectivities. Connectivities between the one device to the another device. That means here internetworking. So in a computer networks now, generally the internetworkings now which is connecting the multiple networks. Connecting internetworking now, data transmission can be done via the multiple networks to, that means to forming the large network. So this is a wide area network. Now this one is a local area network and another local area network, another local area. Number of local area networks are that will be connected to the wide area network. So this is a internetworking. That's why this internetworking, which is having the two terms, that is a inter and a networking. Multiple networks can be connected as a single network and forming as a single other network. By connecting these the multiple network as a single network now, a large amount of data, we can transfer the large amount of data that can be effectively transferred from the source mission to the destination other mission. That is a unified networking. That means unified other networking. So it is facilitated by the devices such as routers. Now in between this networking, in between the source device and destination device now, number of other devices can be arranged here. Via this number of other devices, the data transmission can be done from source to other destination. The devices are the routers and the switches and gateways, and which is enabling the communication between the some heterogeneous other networks. Now different other networks now, the communication can be done very effectively and very reliably. Data transmissions can be done, which is enabling the reliable data transparency and which is enabling the communication. Effective or efficient communication can be done. That is a internetworking. And the key concepts are IP addressing. IP addressing, routing, and here is static routing and dynamic routing. IP addressing. IP addressing, it is a unique address, unique identifier to the destination network. So in a network, now the destination can be identified, uniquely can be identified the destination with help of this IP address. Each and every devices which is having its own IP addresses. With help of these the IP addresses now, easily we can identify the destination and data can be transferred very effectively. Here is the next is the routing. Routing means now routing which determines the best path from source station to the destination station, the best, shortest and optimal path. Optimal path can be find with help of this routing, and by finding this optimal path now, data transparency can be done across the network. Here, why? Because now with this the routing now, by which is determining the best path and optimal path, by determining the best path or optimal path now, here in this the routing, now we can find the best and optimal path. Here the time delay can be reduced. Data transparency, time delay can be reduced by finding the best path between the two other devices. static routing. Static routing here generally is a manually configured routing, and dynamic routing, static routing is a manually configured, it is a fixed. Dynamic routing is a automatically updated using the protocols are OSPF, BGP and RIP the protocol. So suppose if the protocol OSPF or the protocol you are using, automatically the routing will be the updated and changing the routing, and BGP routing and RIP routing, that means OSPF means is the open shortest path first, and the BGP means border gateway of the protocol. RIP means now routing the information of the protocol. Depends upon the usage of this the protocol, automatically routes will be updated. So that is a dynamic routing protocol. Dynamic routing protocol now the best these are GPS Google Map. So Gmap Google Map is working on the dynamic routing protocol. So whatever wherever the traffic is free. So in the traffic here, where the traffic is free, now which is showing that the path, that is a dynamic routing. Updating depends upon this the traffic now, so that routing will be the changes. But a static routing here, so it is a fixed. The path is the fixed. But in a dynamic routing now, depends upon that the traffic, the route will be the updated. So that's why automatically updating the routes using these are the protocol OS the PF protocol and BGP protocol and RIP protocol. Best example for this the dynamic routing is a Gmap, Google Map. Here is the protocols. The protocols are the IPv4 and IPv6. IPv4, IPv6 are the Internet Protocol versions for addressing and routings. So these two are the with help of this the protocol now. IPv6 is the enhancements of the IPv4, Internet Protocol version 4 and Internet Protocol version 6. So these two protocols are the addressing and routing. Best routing can be done with help of these the two other protocols. And ICMP protocol. ICMP protocol means now it is a Internet Control Message Protocol. This Internet Message Control Protocol now finding the errors. Suppose the errors in a routers or errors in a path or errors in a hubs. So devices, whatever the devices now we are going to using between the source and destination. So in these are the devices now, which is this ICMP the protocol, which is the finding the errors, and by finding these errors now diagnostic. After finding that errors now diagnostic can be done. Immediately rectifying that errors and diagnosing can be done here by diagnosing now this ICMP the protocol diagnostic this the property now which is effectively sending the data, which is effectively transferring the data from source to the destinations. That is a ICMP protocol. These are the protocols can be used in the quality of the services and internet working. Internet networking devices. Generally, the internet networking devices are used between the source and destination are the routers and switches and gateway. These are all the internet networking devices. Routers are forwarding the packets between the networks based on the IP addresses. Between the source and destination, now which is forwarding the packets based on the IP addresses. Now, whatever the best path. Whatever the find the by using different algorithms and techniques now, finding the shortest path between the source and destination. By finding the shortest path between the source and destination now, by considering the shortest path, very shortest path, the optimal path now, sending the packets between the networks based on the IP addresses. Switches now which is operates within a single network. Within a single network now, it will be operated and to forwarding the packets based on the MAC addresses. Message authentication of the code now, it will be the packets will be the forwarding. And here is the gateways. Gateways means now which is translating the data formats. Gateways are translating the data formats between the different other networks and other protocols. Here, so this is other gateways and the challenges in internet networking. Challenges in internet networking are scalability, interoperability, and security. So these are all the challenges. The scalability now, which is ensuring the network can grow without the performance degradation. That means now the scalability, what it is doing now, the performance can be improved. The data, if it is a performance improved here, the data without other loss, no, the data packets can be sent from the source to other destinations. That is a scalability. And interoperability now, which is facilitating the other communication. So between the different other protocols and technologies, by using these different protocols and technologies, the communication facility can be provided with help of this interoperability. These are the technique. This is interoperability. This operation is a very effective, which is one of the big challenge for the quality of providing the quality of the services. And the security is another the challenge now, which is protecting the data. Data protection is one challenge. Whatever the data we are going to transferring from source to destination, and that providing security. So it is one of the biggest challenge in a quality of the service or the internet working. And the resources from the unauthorized access and attacks. We have to provide the security. Unauthorized access, attackers, hackers. From that now we have to provide the security. Providing security is a big challenge for providing the quality of service and internet working. For this, the quality of the service and internet working, the textbooks are data communication and networking by the Foregen, and computer networks by Andreas the Tenenbaum. These two textbooks are best for the quality of services and internet working. So this is about the quality of service and internet working. The quality of, finally, the summation of this quality of service and internet working is, so with these are the techniques, different types of these are the techniques now. We have to provide the services without loss. That means the quality of service means without the data loss. Now we have to transferring the data packets from sender to receiver. That's a source station to destination station. So this is about the quality of service and internet working. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.